Good morning, students. Today we are going to discuss some more problems of the Hankel transform. How to find the Hankel transform of some functions. As we know that the Hankel transform of a function fx, the Hankel transform of a function fx with respect to parameter p, this is equals to fp, and this is given by integral 0 to infinite x j nu px fx dx. In the Hankel transform, we see that the well-known Bessel function involved, the Bessel function of order nu. Here x j nu px is the kernel of the transformation. J nu px is the Bessel function of order nu. So here the order of the Bessel function involved. So we can write this one as f nu p, and the Hankel transform can be written as h nu fx with respect to parameter p. Here nu is known as the order of that Bessel function or order that of that transformation. So by using this one, we have to find the Hankel transform. Find the Hankel transform of fx, where fx is equals to the function fx is given as x raised to n if x lies between 0 and a, and it is 0. X raised to n, it is 0 if x is greater than a. Or we can write that fx is equals to x raised to n h of a minus x. Here h of a minus x is the Heaviside function, is the Heaviside unit function. So we have to find the Hankel transform of the function, which is defined as fx is equals to x raised to n if x lies between 0 and a, and it is 0 if x is greater than a. So for this solution of the problem, we find the Hankel transform. The Hankel transform of the function by taking the kernel h, the kernel of the transformation is x j n px, x j n px. The kernel of the transformation is this. So the solution of this problem, the solution of the problem is Hankel transform of the function of order n. So hn fx with respect to parameter. By definition, this is equals to fnp, and this is equals to integral 0 to infinite x jn px. This is the kernel fx dx. As the function is given in different intervals, or the function is defined in different intervals, so first we break this integral in those intervals in which the function is defined. So this is equals to integral 0 to x, integral 0 to a x jn px fx dx, plus integral a to infinite x jn px fx dx. In the interval 0 to a, the function is x jn px, this is x raised to n dx, plus integral a to infinite x jn px, and in this interval the function is 0 dx. So we remains with the interval 0 to a x raised to n jn px dx number 1. This is f and p. Now, in order to find this Hankel transform, we have to integrate the right hand side of equation first. For this, we have to use the recurrence relation for the Bessel function. We know by the recurrence relation for Bessel function that what we know is that d by dx of x raised to n jnx, this is equals to x raised to n jn minus 1 x. This is the recurrence relation for the Bessel transform. Now, if we replace x by px and n by n plus 1, then we get, if we replace x by px and n by n plus 1, if we replace x by px, then dx is equals to p dx. So this recurrence relation is d by p dx, x raised to n, that is p raised to n, n by n plus 1. So this is p raised to n plus 1, x raised to n plus 1, j n plus 1 dx. This is equals to x raised to n plus 1 j n dx. If we replace the result, that d by dx x raised to n by n plus 1 and x by px, then we get this result. So we get this result h. This is on the right hand side, this is p raised to n plus 1 also, as x is replaced by n plus 1. So we get here this is x raised to n plus 1, as x into x raised to n, this is x raised to n plus 1. So we remains with 1 d by p dx of p raised to n, both sides cancelled, x raised to n plus 1 j n plus 1 px, and this is equals to x raised to n plus 1 j n px number. So putting the value of x raised to n plus 1 j n px from equation second to equation first, so using second in first, we get f and p rather, f and p is equals to integral 0 to a, and the value of x raised to n plus 1 j n px is equals to 1 upon p d by dx of x raised to n plus 1 j n plus 1 p dx, and this is equals to 1 upon p integral 0 to a d by dx of x raised to n plus 1 j n plus 1 p dx. On integrating this, we get 1 upon p x raised to n plus 1 j n plus 1 p limits are from 0 to a. Putting the limits, we get f and p is equals to 1 upon p, a raised to n plus 1 j n plus 1 p, which is the required result. So, by the use of the Bessel functions, we can find the Hankel transform of the function. Thank you very much.